Hi, it's Allison from East Cobb Tutoring Center. Let's graph tangent and cotangent. So I have a t-table going over here with some important values from the unit circle. The tangent at negative 90 degrees is actually undefined, right? Because it's sine over cosine. In the cosine, there's 0. So same thing happens at positive 90. The tangent at negative 45 is negative 1. The tangent at 0 is 0, and the tangent at 45 degrees is 1. Now, when we go to our graph, the spaces which are undefined at negative 90 and positive 90 behave like asymptotes. So I'm putting in dotted lines at negative 90 and positive 90. Now, tangent is the only graph that we're going to graph half on each side of the y-axis. Everything else, we tend to graph a period of the function just on the positive side of the x-axis, but tangent we're going to graph half and half. It goes through the origin, just like sine does. There we go. And then at negative 45, we're at negative 1, and positive 45, we're at positive 1. Here we go. Whoops. Hold on, I just opened something on my screen. Alrighty, let's try that again. There we go. So this is what one period for the tangent graph looks like. If your teacher wants you to draw a second one, then you can notice that the period here is 180 degrees. So you would just move on down the line 180 degrees from 90, which would put you here at 270. So dot, 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 that's the next asymptote. It would go through the center, and it would follow that same general shape, something like that. All right, now let's take a look at the parent graph for cotangent. Here's my t-table again. The cotangent at 0 is undefined because it's sine over cosine, and the cosine is 0 there. So let's put in that. Same thing's going to happen at 180. The cotangent of 45 degrees is 1, and we'll have 0, and we'll have negative 1. All right, so at 0 and 180, I'm going to put in my vertical asymptotes. Here we go. It goes through 90 degrees, which is right here. And then it behaves kind of in the opposite direction of tangent. So it's going to fall as we go from left to right, like that. Okay, and just like with tangent, if your teacher wanted another period of the graph, you can see that from here to here is 180. So just go 180 degrees down the line. That would put you at 360, make another asymptote, and then just, copy the picture over, something like that. All right, so now let's do some transformations on these guys. We're going to stick with degrees for now. Let's do y equals 3 tangent x over 2. We called this number in the front here a, just like we do for sine and cosine, but it's not really an amplitude. Amplitude implies that there's a top and a bottom, but tangent doesn't have a top and a bottom because of the asymptotes. Another difference between tangent and the sine and cosine graphs is that the period for sine and cosine is 2 pi, but the period for the tangent parent graph is 180 or pi. So I'm going to write 180 over b. In this problem, b is not 2, it's 1/2. So you've got to be careful there. That means the period is 360 degrees. All right, now watch how I graph this. I'm going to put half the period on either side of the x-axis, so that of the y-axis. So all together, it's equal to 360 degrees. Those are where the asymptotes will go. I'm going to mark the middle, which is here, and then I'm going to mark the halfways. So halfway between 0 and 180 is here at 90. All right, so dot, dot, dot. Those are my asymptotes at the ends there. Oops. And then at negative 90, I'm going to be at not negative 1 because that a value is 3. So it's going to put me all the way down here at negative 3. And the other one's going to go up here at positive 3. So even though we've got these changes to the A value and the B value, the general shape will remain the same. All right, let's do a transformation on cotangent now. Let's make up y equals, oops, that got messy. Let's undo that. Try again. Y equals, let's do 2 cotangent of 3x. All right, so the value of A here is 2. And remember, the period is not 360, it's 180 over B. So 180 over 3, that's going to give me 60 degrees for my period. So I'm going to graph this kind of the same method we use for sine and cosine, where I go to the end of the period, which was at 60. Oh, this is very squishy. All right, well, that's going to be here. Then I mark half of that. Oh boy, half of that. Oh no, this is way too squishy. Let's change our, let's see, what can we do to fix this problem? My idea is that I'm going to change the numbers on my axis so that we can fit everything on here. Otherwise, it'll just be too little to see. So let's instead make this guy here be 60 degrees. That means that this is going to be 30 degrees. This will be 15 degrees. And then this guy over here will be 45 degrees. That should solve our problem. Okay. All right, so I'm counting by 15. So that means that this guy would be 90 and this guy would be 180. There we go. Okay, that'll fix our problem. So the period is 60 degrees. So I'm going to go to the end of the period and mark it. Here's the beginning, right, at 0. I'm going to mark half of that, and times it by 3. All right, the asymptotes go at the beginning and the end, so it's 0 and 60 degrees. Cotangent goes through its center here at 30, and then it falls as it goes from left to right. Now, our A value is 2, so I'm going to line up 15 degrees with 2, and I'm going to line up negative 45 degrees with negative 2, and then I'm going to draw in my cosine graph like that. Cotangent graph, sorry. All right, and if your teacher wanted one more, you would just copy the image over again, something like that. Just don't forget to put in your other asymptote. All right, so now let's take a look at the same thing, but this time in radians. I'm going to skip the parent graphs this time, so let's just take a look at some transformations. What I'd like to show you is what happens when we make tangent negative. So let's do negative tangent of x over 3. Let's start by identifying A and the period. The A value here is 1. The negative does something else. That's the reflection. And the period is not 2 pi over b, just pi over b, because we're talking about tangent. So it's going to be pi over 1/3, not pi over 3. Be careful. So the period is 3 pi. Remember the way we graphed the tangent graph is we put half the period on each side. So that's half of 3 pi is 3 pi over 2. That's where the asymptotes go. Negative 3 pi over 2. And it's going to go through the center here at 0. And then the A value is 1, which I'm going to mark. Now, normally, tangent would rise as we go from left to right, but because of the negative, it's going to go in the opposite direction. It's going to fall. So half of 3 pi over 2 is 3 pi over 4. Let's see, 1, 2, 3. I think that's going to be right around here. And right around here. There we go. And then we just draw it in. So this guy got really wide, and it's going in the opposite direction. It looks like cotangent, but cotangent wouldn't go through the origin unless it was shifted. So let's do one more example, and then we'll be done. Let's take a look at cotangent now. We're going to do a transformation on that. Let's do y equals the cotangent of, let's do x over 2. So the a value, let's put 1 in here. Let's put 4. The a value is 4, and the period is pi over 1/2. Let's see, pi over 1/2 is going to give us 2 pi. All right, so I'm going to go to the end. That's the asymptote. Here's the other end. The a value is at 4. Here's -4. The center is pi. And remember that cotangent falls as it goes from left to right. So I'm going to be here, halfway here, and there it is. Whoa, that got a little bit sloppy, but I think you get the idea. I could probably try to fix that a little bit. All right, so there is our transformation of the cotangent graph. So we've got tangent and cotangent in radians and degrees, the parent functions, changing the amplitude and the period.